If a developer I was working with asked, "Why did you select that font?" it's pretty unlikely they'd accept self-preservation as my answer. Type designer Pierre Haultin may have actually been able to get away with this claim. He lives and works in Paris during the mid-16th century, and how the type he designs performs, how efficient it is spatially on the page, is actually much more relevant to his personal safety than it is for his contemporaries. The work of type designers today, people who design fonts professionally, is still historically linked to these 16th century craftspeople called punch cutters like Haultin. While typefaces designed or revived more recently, ones that you may be using on screens, probably started their life as a sketch and then were worked on digitally quite quickly, a typeface designed for books in the mid-1500s would have started its life in steel. Having the ability to print, publish, and design type in this matter affords Haultin a more active role in what we might now call the design process, and his skills enable him to explore issues of typographic efficiency through the design of type itself. Centuries on, it's no longer just the punch cutters or the type designers or the printers who are responsible for the performance of type. That group has expanded to include typographers working on the web. And whether you see yourself this way or not, you probably are a typographer. While type designer is the name given to the designers of typefaces themselves, this is Mrs. Eves, designed by Zuzana Lichko, for example, typographers are the people who use them. This means that today, designers, developers, and anyone using a word processor are setting type in ways that couldn't have been anticipated back when it was being cut out of metal. And whether you take on the title graphic designer, front-end developer, software engineer, or something else entirely, we still have a similar question to the 16th century punch cutters. How might a text be received and read more efficiently? We can continue to suggest answers to this on the web today by making the most of the existing practices we have, taking advantage of upcoming technologies, and viewing the punch cutter's process as a precedence for designers having a major role to play in the performance of type. Depending on how long you've been working with fonts on the web, these might not exactly sound like recent challenges, but I can assure you the ones that Haultin were working on were even older. He's working on the Bible. Historically, religion has driven lettering, type design, and a great deal of communication in general. The first mechanical movable type printing press was invented by Johannes Gutenberg 100 years before Haultin's working, and as he prints the iconic 42-line Bible, it becomes the fastest book ever produced. So what could possibly make printing a Bible a worthy challenge for someone as skilled as Haultin an entire century later? Certainly, he knows how to create effective work, and this is not where his problem lays. His ability to print, publish, and design type means he's more than capable of producing a version of the Bible. No. Haultin's requirements come from a secret that he's keeping. In addition to being a printer, a publisher, and a proficient punch cutter, he's also a Protestant. Protestantism is essentially a forbidden branch of Christianity in mid-16th century Paris, and its members are known as Huguenots, though Haultin has managed to keep his own beliefs a secret up until this point, largely for his own safety. Through improvements in printing technology and secret promotional efforts of people including Haultin, Catholics are increasingly converting to Protestantism, and this does not sit well with the most powerful Catholics in the country. They're unimpressed and impose a religious repression on Paris, one that steadily worsens under the newly crowned King Henry II. Now, this is a religious disagreement and one that I'm not an expert in, and I'm sure any number of people could be blamed. And when we look back at Haultin, he's hardly a guiltless figure either, but it's still hard not to see the king as the person in power, as the villain here. He gets a lance through the face in about 3 years from now, if that makes you feel any better. But in the meantime, yeah, jousting tournaments, you know how it is. But in the meantime, this is the position that Haultin finds himself in, with a desire to practice his faith, but he's facing death in doing so. Like many designers and developers today, Haultin builds his own tools to solve his own problems. And as his concerns with the religious climate in Paris grows worse, so do his concerns with the design of the Bible itself. I became interested in Haultin's story through the books The Paleontography of the French Renaissance by H.D.L. Vervliet and Counterpunch by Fred Smyers. In the latter, Smyers speculates what's going through Haultin's mind at this trying point in his life, but I prefer to think he would have asked more directly. "Why do people keep making these large and heavy Bibles?" he probably prayed. "I need to be able to pick up my things and move quickly. I don't want to be discovered practicing my faith, but how might I make these books smaller?" In essence, this leads haultin to help design what's the first French language pocket Bible. He's constrained by how small the type can be while still remaining easy and desirable to read. Its spatial efficiency on the page determines how physically small this Bible can be. A typeface that reads well at extremely small sizes means less pages to print and a more reasonable number of characters per line. And haultin approaches this by experimenting with the extreme ends of the parameters he wants to design within, something that's still common in type design today. This is a fairly low-quality example compared to the caliber of work that haultin's doing, but it illustrates how this is still happening with type designers today. By designing an extremely heavyweight and an extremely lightweight, you can generate instances in between to try and figure out where the parameters you're looking for exist. haultin, however, is looking for adjustments that apply to size-specific type that's working at a very small size and will improve its spatial efficiency. And remember, at this point in time, he's physically cutting the type out of metal. This is an actual object, and he has to work at it at scale. There's no vector tools to zoom in, and there's no drop-down for him to change from 10-point to 12-point or vice versa. He actually has to design the typeface at that size. But he's actually technically skilled enough to overshoot his goal and make something that works, but he realizes is too small. And he can do this along the way by taking that metal type, holding it over an open flame, covering it in soot, and pressing it into parchment. And that gives him feedback about his design decisions. He eventually finds the spatial sweet spot for his book typeface and now can print a gorgeously inconspicuous Bible. haultin's performance issues in type design mirrors our performance issues on the web. How may the text be received and read more efficiently? He suggests answers to this through the design of the type, but based on our challenges today, that's not the only place this needs an answer. However you may be referencing fonts on the web, manually hosting them and writing your own font face declarations in CSS, or using a service like Typotech, Typekit, Fonts.com, or Google Fonts, it's clear you are referencing more fonts. The adoption of FontFace and WAF, the web open font format, has been rapid. And these services actually mean it's even less likely that you're writing these FontFace declarations manually. But when you drop in a CSS file or a JavaScript snippet from one of these services, this is what you're still getting back. So let's just review FontFace quickly and how it works together with WAF. You can specify the font family name that you want to use elsewhere in your CSS. The font style, in this case, it's normal as opposed to italic. The font weight, which in this case is 300 because that corresponds to the lightweight of the typeface, which is what we're loading in. In 2009, the biggest challenge with WAF was adoption. Its goal was to firmly establish a way to use true fonts on the web. And thanks to the hard work of the Web Fonts Working Group and many other people, it's safe to say that this happened. Based on data from the HTTP archive, we can see an increase from 1% of fonts in sites using real web fonts in 2010 to, actually, this doesn't seem sufficient. Okay, there. To 50% at the beginning of this year. That's a massive increase. And to look at one typeface specifically, Open Sans, which was released as recently as 2011, it's now more commonly used than Lucida Grande, a commonly sanctioned web-safe font. Here are some things that happen less often per day than the number of times Open Sans is served. YouTube streams of the top video of a day, that's less. We see 350 million Facebook photos uploads in a day. We can see 500 million tweets in a day, but that doesn't come close to the 2.45 daily Open Sans font views according to Google Fonts. And this doesn't even factor in other flavors of Open Sans like Condensed or Open Sans Hebrew or other places it's being served from. Now, keep in mind I'm about as much of a statistician as I am a French religious historian, which is to say that I'm only interested in it when it relates to typography. But I guess the point I'm really trying to make is, like, chill out with the Open Sans. And also this. In adopting real web fonts, we've also adopted some performance problems. We're building sites that request more fonts, and they're bigger too. We've gone from an 8 kilobyte average to 59 kilobyte average in 2 years from 2012 to 2014. And to mitigate this, most font face generators and web font services are subsetting fonts by default, removing characters that are deemed to be unnecessary, regardless of what the type designer originally intended. While subsetting is often worthwhile, it also imposes many limitations that aren't immediately obvious. And this is something I discovered while maintaining normalized OpenType CSS, a style sheet that, like its namesake normalized CSS, aims to provide sound CSS defaults across browsers, but specifically for these advanced typographic features. With normalized OpenType CSS, we see ligatures turned on by default as they're supposed to be. Discretionary ligatures are used in headlines. Small caps can replace all caps settings in text settings, which are less distracting when you're trying to create something good for long-form reading. And we can use old-style numerals instead of lining numerals, which are also less distracting in text settings. If you're using script typefaces, you can turn on alternate glyph settings, which make them much more versatile. And for some languages, there are actually OpenType features that are necessary to use that language properly, or use those fonts properly for certain languages. But in practice, browser inconsistencies by setting these features on by default are actually less of a problem than those ligatures, alternate glyphs, and other design considerations being subset out by default. Simultaneously, we're expecting more and more type on the web, yet aggressive subsetting means cutting down a typeface to only support certain features by default. And sometimes other languages are supported through other fonts entirely, but the issue still stands and we need to pay attention to it. More and more readers are coming online and rightfully expect to be able to read in their own language in an appropriate typographic voice. When writing and speaking about some of these performance problems in relation to type, it's sometimes common to only place them in their immediate context, but the reality is a lot of people have been working on challenges like this for a long time in other formats, and many of those people were actually designers. We saw how, in the mid-16th century, haultin approached inefficiency through space-saving metal typefaces themselves, but our current technology renders the same point of intervention less impactful. This discovery was shared by Matthew Carter, a highly respected type designer well known for making both Georgia and Verdana, so you've definitely used his work. When he spoke in Vancouver, he mentioned the need for efficient type in the mid-1980s. How might we use serif fonts, which required significantly more storage space at the time, on a machine where space was extremely limited?
At that time, with the size of the fonts, the amount of data that was required to define and store a font in computer memory. It limited the number of fonts you could get on your typesetting system at any one time. I did an analysis of the data and found that a typical serif face you see on the left needed nearly twice as much data as a sans serif in the middle, because of all the points required to define the elegantly curved serif brackets. The numbers at the bottom of the slide, by the way, they represent the amount of data needed to store each of the fonts. So the sans serif in the middle, sans the serifs, was much more economical, 81 to 151. Aha, I thought, the engineers have a problem. Designer to the rescue. I made a serif type, you can see it on the right, without curved serifs. I made them polygonal out of straight line segments, chamfered brackets. And look, as economical in data as a sans serif. We call it charter on the right. So I went to the head of engineering with my numbers and I said proudly, I have solved your problem. Oh, he said, what problem? And I said, well, you know, the problem of the huge data you require for serif fonts and so on. Oh, he said, we solved that problem last week. We wrote a compaction routine that reduces the size of all fonts by an order of magnitude. You can have as many fonts on your system as you like. Well, thank you for letting me know. I said, foiled again.
The engineers managed to compress every font on the system. Oh. Well, constraints can lead to amazing results as they do in this case, and Matthew Carter still goes on to design that amazing typeface charter by imposing those limitations upon himself. But as he notes, this doesn't end up being the most impactful way to approach the problem. We're now in a similar position on the web. The designer has a role in web performance of type, but solving our problems within a single typeface itself, as haultin did, as Matthew Carter ended up pursuing for other ends, no longer has the same impact. The intervention must come at the level of the system, not within the implementation of an individual font. Thankfully, the Web Fonts Working Group knew just this, and with the adoption of WAF, they were able to turn their attention to refining that existing implementation. And the result of their work is aptly named WAF 2. From a technical perspective, WAF 2 sounds a little bit too good to be true. What if you could continue to use the same interface for fonts you're already familiar with font face or a font service, but soon you could expect the fonts requested to be significantly smaller in file size. Well, this is possible largely because of the brotli compression algorithm applied to WAF2 files. Brotli is a generic-purpose lossless compression algorithm that uses a bunch of compression techniques I will probably never understand in my lifetime. It provides denser compression than WAF while maintaining a good decompression rate on mobile devices, so it's still very successful at that. And when various type Foundry and web font service catalogs were run through this brotli compression algorithm by the web fonts working group, we see some massive improvements. There was a 14% improvement on Typekit's TrueType catalog and a 27% improvement along the rest of their catalog. And this is mirrored in the monotypefonts.com catalog, which sees a 25% compression improvement over WAF files. The best observed compression rate for a non-Latin typeface was 60%, which has some pretty amazing implications for using real web fonts in other languages successfully. And one of the best things about WAF2 is really one of the best things about font face. The font face specification cleverly anticipated the need to support multiple formats simultaneously. So even though WAF2 is new, there are no changes to the CSS syntax itself. To continue with this example before, you might have loaded in a WAF file but also wanted to support older devices. And ignoring some Internet Explorer inconsistencies, we can see how we can load in an embedded OpenType file to support older Internet Explorer versions. And in the same way, we can also fall back to a TrueType font file if WAF isn't supported either. Well, I wouldn't recommend doing this anymore now since WAF is so well supported, but it serves to illustrate how we can do the same thing with WAF2. We can optimistically support this new format by placing it above our WAF declarations. And if the browser supports WAF2, that will be loaded. And if not, it will fall back to the original flavor of WAF. Now, if you're using a web font service to provide your fonts, this is the kind of CSS file you're getting back. And it also means when you're requesting that, you might actually already be using WAF2 and not even realize it. A few months back, Open Sans Hebrew and some other Google Fonts early access typefaces were switched over to WAF2. So when you requested them, you would get a CSS file back. And if you actually went in and investigated it, you would see you would be getting WAF2 files in browsers that supported it. And since then, Google Fonts has gone on to add this for everything in their catalog. So if you're using Google Fonts, you're already using WAF2. Sadly, this isn't the case for pretty much every other web font service, but you still have the opportunity to generate WAF2 files yourself if you're self-hosting. One way to do this is by cloning Google's implementation of WAF2 and running it locally on the command line. And so you give it a TrueType font and you'll get a WAF2 file back. And if that's less appealing to you, you can also use Font Squirrel, and as long as you make sure to use the expert settings and sort of uncheck the other things that mess with your font, you can convert to and from WAF2 fairly easily. Now, it's important when you're self-hosting fonts to check your licenses and make sure you know what you're allowed to do. Most foundries and distributors are usually run by small, personable teams, and it's a good excuse to say hello to them and say that you like their typefaces, and also ask them to generate the WAF2 files for you. It'll be much more success. A lot of them were actually totally happy to do this, and they're just a little bit behind on doing this. And hopefully by asking for them, we can encourage performance improvements at the level they should be at so everyone can get WAF2 files rather than just generating them ourselves. Really, one of the only downsides about WAF2 is the browser support, which is actually still not too bad. It's been supported in Chrome since 36 and Opera since 23, and it's now in the latest version of the Android browser. It's in Firefox Dev and Nightly editions by default, but it's turned off on under a flag in the main version of Firefox, but hopefully that means it's getting added soon. And it's under consideration for IE. But since fallbacks are already built into the way we're using it, there's really no excuse to avoid using it now. And this might make it seem like the performance of web fonts is purely an engineering challenge that's been solved. As Matthew Carter discovered, software engineers are capable of creating these massive performance improvements at the level of the system, making our one-off improvements sometimes seem ineffective or small. But I see WAF2 as an opportunity to reconsider what's really important in the performance of type. With WAF2 files being dramatically smaller, there's an opportunity for designers and front-end developers to turn their focus instead to perceived performance and other client-side optimizations instead. So some recommendations I have for this are to skip base64 encoding fonts into your CSS files. In practice, they're harder to maintain and they don't actually give you any benefits really. So if we have a file like this, we have the option of base64 encoding all the fonts into the single CSS file. But in practice, this means if we're supporting a lot of formats, we're actually dramatically increasing the size of our CSS file, rather than just asking for the specific font file that we need. And the performance improvements we see from doing that, from reducing the HTTP requests, rarely turn out to be as good enough to balance the trade-off of having the much bigger CSS file. So just stick with the original format. It's easier to maintain as well. And also, if you're using a web font service, stop using the CSS-only approach. A lot of them will say, you don't have to use JavaScript. You can just take a link tag or an import statement and drop it in. But in practice, this doesn't give you the level of control you need when loading in fonts. If you look around, there's probably an advanced option or a JavaScript option, and they'll give you a snippet to paste in instead, which is probably using the web font loader under the hood, which is maintained by Bramstein. And just to show you some of the power that the web font loader has, I wanted to see how many different web font services I could load in fonts from at once. In practice, you wouldn't want to do this. It's too many. But we can see how configurable this tool is. So I'm going to load in Charlie and Echo by Ross Milne from Typotech, Nadine Shaheen's Fruitiger Arabic from Monotype, Elisa Nowak's Escapade from Type Together via Typekit, James T. Edmondson's Lavanderia from Lost Type, and Yannick Yonsef's Open Sans Hebrew from Google Fonts. So we can do this all in one configuration object with the web font loader, rather than copy and pasting snippets from each one of those services, which are probably all using this exact same open source project anyways. So we can ask Google for Open Sans Hebrew, Typekit, give them our kit ID for Escapade, Monotype, again, give them our ID, which we've configured on their website. And then Lavanderia is self-hosted, and you can specify different weights. And Typotech, we get this configuration object. And now in practice, again, you wouldn't want to load this many fonts at once, but now that you have the web font loader project in your page, you can also decide to load some fonts earlier and some fonts later. So you can say, these are the most critical ones I need to get on my page, and I can defer some of these until after the initial load. The web font loader also allows us to load our fonts in asynchronously. And this is really important because, as Tim Brown of Typekit points out, our view of typography on the web should be centered on the principle of progressive enhancement. That a text itself is fundamentally more important than our ideas about how it should be typeset. And this is hard for typographers to say, but it hurts a little bit. But it's true, because the type is there in service to what we're trying to read, and we need to prioritize that. So by loading things in asynchronously, either using script injection, which is described in the web font loader README, it's usually just a matter of copy and pasting, or by experimenting with the async attribute, we can have our fonts loading in asynchronously and improve the experience there. And Scott Gell, who we're lucky enough to have here with us, has also written a fantastic article about font events and Bramstein's newer version of the web font loader, which is called Font Face Observer. So if you want to use something more bleeding edge, I highly recommend this article. But in each case, what we've done is created an opportunity for a flash of unstyled text. And yes, this is an opportunity. As Bramstein has said, FOUT is a feature and a condition, and everyone should anticipate and design for it. With the web font loader, we get to specify a timeout. How long do we want to wait before we give up on the fonts or before we show that fallback text? And this is an opportunity to make that number much lower. We don't want to make people wait for what they have to read, especially if their connection is poor. So we can lower that to 2 milliseconds to 1.5. It's worth playing with that number. But in any of those cases, it really means that font stacks still matter. This is something that I see really often in web font services. They'll say, here's the font that you're going to use, and you can just paste in this little bit of CSS. Soleil is the typeface, and sans serif, and that's your entire font stack. And I don't know, but I don't know if 2 things counts as a stack. I'm not really sure about that. When I see references like that, it kind of makes me feel like I got a lance through the face. I don't know. It's really upsetting to me, because font stacks are still really important. Font family is this amazing property where we have progressive enhancement built in. We can specify all the fallbacks, and regardless of the devices and the fonts they have installed, we get to specify what's optimal in each of those cases. So for my slides, this would be the font stack I'm using. We can use Avenir next on more recent OS X and iOS devices because we have it available. But we can fall back to Futura on devices that have it, and Droid Sans where that's the only option. And it's important to think about the order of these two because that does matter. So you will always want to put Helvetica Neue before Arial, for example. But this allows us to just think through the fallbacks we want to provide. And this might seem like a lot of work and something that's kind of old school, but I think it's actually still really relevant because if you're doing something with a visual identity where type is very important, which is pretty much every visual identity, you're probably also sending email newsletters or emails somewhere in that system. And you can save all of this to a variable in your preprocessor and reuse those for email templates. Emails only about 25% of clients at best support web fonts. So this actually becomes pretty reusable in some of your other projects. Pierre Haultin's endeavored to improve spatial efficiency and enable more contextually appropriate communication in his day. And though the issues driving our optimizations are not really as dire, they're perhaps more relevant than ever. It's clear there's a need and a precedence for designers improving typographic performance problems. And by looking ahead to new technologies, WAF 2 and the inherent performance problems that it brings, and taking the opportunity to employ other established practices in the meantime, we can make our own suggestions about how a text might be received and read more efficiently. There's precedence for designers' role in the performance of type on the web. And too often, the way we view and present our work, it can be easy to get caught up that what we're doing, designing, and developing is entirely new. And I'm as guilty of that as anyone. But to me, there's something more wonderful about being reminded we're far from the first to try and improve the effectiveness and efficiency of our communication. Whether you're cutting the smallest readable metal type or just trying to make your fonts feel like they've loaded a bit faster. Thanks.